Okay, welcome to my video on graphing parabolas. And today I'm going to teach you basically the multiple different parts of graphing parabolas that you need to know, such as recognizing quadratic relations, how to graph in vertex form, how to graph using factored form, the quadratic formula, on and on. Let's get started. What is a quadratic formula, you may ask? And so for that, I have this equation right here, which we'll use as an example, y equals x squared. And so what we can do is we'll just start with -3, -2, -1, 0, 1, 2, 3. And now let's just sub it in there. We'll have -3 squared is +9, -2 squared is +4, -1 squared is +1, 0 squared is 0, 1 squared is 1 again, 2 squared is 4, on and on, like such. Well, you'll say, okay, there's a bunch of numbers. Well, how do we know if it's a quadratic relation or if it's just a linear one or if it's neither? Well, this is how you know. So we know what the first difference is. The first difference is when you take 9 and subtract 4. 9 subtract 4 is 5. 4 subtract 1 is 3. 1 subtract 0 is 1. On and on. So that's not a linear equation. But because the first difference is it's constantly changing. So, well, how will we know if it's a quadratic relation or not? Let's check the second differences. What's 5 minus 3? 2. What's 3 minus 1? 2. Over here, what's 0 minus 1? -1. What's 1 minus 4? -3. And then what's 4 minus 9? -5. What's 1 minus -1? That would be 1 plus 1, 2. What's -1 minus -3? That would be 1 plus 3, so it would be 2 again. And then what's -3 minus 5 would be +2. As you can see, these second differences are constant. They're all the same. So if we're given an equation and we write out a table of values and we look for a first and second differences, if the first differences aren't constant, check the second differences. And if the second differences are constant, like as in here, in this case, then that means that this is a quadratic relation. So now how exactly would you graph this? Simple. We already have the points right here for this equation. So let's just go ahead and put them up in this graph I made earlier over here. So 0, of course, is 0. It's going to pass through the origin. Then we have 1 on both sides is equal to 1. By the way, the scale is just going up by 1, in case you were wondering. And then 2 squared would be 1, 2, 3, 4. And then 3 squared, 4, 5, 6, 7, 8, 9. Like that. Now, let's connect the dots. It'll go like that. Doesn't really have to be perfect. No need for a ruler either, because you're dealing with curves. And there we go. That is y equals x squared graphed. This is what it looks like. And now you'll notice it has a really unique shape to it. This curve here is called a parabola. All quadratic relations when graphed should be looking like this, like some sort of parabola. That doesn't mean they'll look exactly like this, because they'll be on different parts of the graph, or they'll have different skinninesses or fatnesses or whatever you want to call it. but they'll have this similar type of curve, which is called a parabola. And so that's that. So like let's do something else. So this is just a simple y equals x squared. Now let's do y equals 2 squared. Just to kind of show you what we're doing here. 2x squared. Let's make a table of values for that. X and y. And let's keep it the same x values. So what's negative 3 squared? 9. What's 9 times 2? 18. This is obviously going to be 18 over here, because we already know this is going to be a quadratic relation. What's negative 2 squared? 4. What's 2 times 4? 8. What's negative 1 squared? 1. 2 times 1, 2. And 0. Now let's graph this one over here. So over here we have y equals x squared. Now let's see what this one looks like. So it's still passing through the same origin. Then we have negative 3 equals 18. So 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14. Well, it goes off the graph, but like you'll get my point. So like negative 2 is equal to positive 8. So 2, 3, 4, 5, 6, 7, 8. 1 is 2. Then we can just do the same thing over here. And then we graph this. As you can see, similar sort of curve. Let's just write this over here. Similar curve, but as you can see, it's a bit skinnier. And we'll get to that in a bit later as to how it got skinnier and what this means. So if we go on and flip to our next page, we'll have I wrote out something over here, and this is called the vertex form, which is on the website. If you need to learn more about it, which you should. But basically, vertex form is y equals ax minus h squared plus k. This all seems a little overwhelming right now, but let me kind of decipher it. So the a right here is equal to your vertical stretch. So what we did in the previous example, which was y equals 2x squared, how is this related to that? Well, your 2 would be your a, and that would be your vertical stretch or compression, depending on what it is. So like, it is a little tricky, but like you'll get the hang of it. So this would be your vertical stretch or compression, and it'll basically change how skinny or narrow your graph gets or how wide it gets. Your x is obviously the same as this, but then minus h. And minus h is going to be your horizontal translation. So this is going to tell you on the axis how much you move to the left or how much you move right. And then plus k is going to tell you your vertical translation, where around the graph. Now, it's called vertex form, and that's because the negative h is your x value and the k is your y value, and it's giving you the vertex of the graph. So basically, if you go ahead and look at negative h, also realize that the signs get switched. So let's say, for example, it's a negative 1. That means your x-axis value would be positive 1. The signs get switched. And if it was a positive 1, then your x-axis value would be a negative 1. So if it was a negative 1, like x minus 1, then that means that you're moving to the right. You're going positive. And if it's x plus 1, that means you're going to the left and you're moving negative. I'll show you an example later. And then the k is your vertical translation. So obviously if it's plus 1, you're moving up 1, positive. And if it's minus 1, you're moving down 1. And let's just think of the fact that, remember y equals x squared? You're basically moving that same equation. But this, and this change it depending on where it's going to be, start, and how it's going to open up. Another thing I forgot to tell you is that if a is negative, that means the graph opens downwards. So if I was to show you this example over here again, these graphs are opening upwards because they're going upwards like that. If they were to open downwards, if let's say it's y equals squared, let's say it was y equals negative x squared, then that means that your a value would be negative 1 and you would be in fact moving downwards. It would be open, the parabola would be opening downwards, which changes things just a little, but otherwise it would, y equals negative x squared would have the same shape and start at the same point. It would just open downwards. So going back over here, I'll talk more about this in a second. So we have y equals a x minus h squared plus k. Don't worry about the square just yet. It's basically the same as this. So vertical translation. Let's do something quite simple. Let's do y equals negative x minus 1 squared plus 1. And so we'll go over here and let's just kind of jot down, let's see. So negative 1 plus 1. What would our vertex be to this equation? Well, our vertex would be negative 1. Flip the sign, it becomes a positive. So 1. And then our y would be 1, 2. So then let's go ahead and find that over here. So obviously be right there. And that's where our graph is going to start. That's where our parabola is going to go start. But let's also realize one thing. Is since there's a negative in front, that means this graph is going to open downwards. So instead of going upwards, it's going downwards. And let's go ahead and just solve for it. Let's make a table of values actually. Just very quickly. X, y, negative 3, negative... Oh, well, I just realized something. Since we shifted over 1 on the x-axis, always try and do kind of... What I like to do is 3 points to the left and then 3 points to the right. So then the values we'll have to find are x equals 0, x equals negative 1, x equals negative 2. And x equals 2, x equals 3, and x equals 4. So let's go ahead and do that. So 0, hold up, negative 2, negative 1, 0, 1, which is where we are right now, 2, 3, 4. Negative 2. Okay, so I'm back. So now that we have our kind of x out values written out, let's go ahead and sub it in that spot. So negative 2 minus 1 would equal negative 3, right? Negative 3 squared would obviously be 9. And then negative 1 times 9 would equal negative 9. Plus 1 would be 8. Simple enough. And then this is our point right here. So we already know that 1 is going to be at 1. And then we can go ahead and put 8 over here because we already know 4 minus 1 will equal 3. 3 squared again is 9. Negative 1 times 9, negative 9 plus... Sorry, just realized something. Negative 8. So this will be negative 8 too. Negative 1. What's negative 1 minus 1? That's going to be negative 2. Square that. Positive 4. Negative 1 times positive... Oh, fuck. Almost dropped the camera there. Where was I? Negative 1 minus 1 would be negative 2 squared. Would be positive 4. Positive 4 times negative 1 would be negative 4. Plus 1 would be negative 3. Go ahead and write that over there. And then 0 minus 1, obviously negative 1. Square that, 1. 1 times negative 1 is going to be negative 1. Plus 1 will be 0. And then 2, right there, would be 0, 2. So let's go ahead and put these points on the graph right above. So we have our vertex right here. And then the 0 was going to be 0. And the 2 was going to be 0, 2. And then negative 1 was going to be negative 3. So negative 1 there. I'm going to put that down there. And then this was going to be a negative 8. So and then now that we have our few points, we can go ahead and just kind of graph it out. And there you go. You have your parabola. So it's quite simple. I would try and do something more complicated, but like you'll kind of get the point under the vertex part of the website. So there's no really need to get too complicated, just trying to show you exactly what all of this means. And so obviously, let's say we put a 2 there instead. We already know that the thing would be opening upwards. The parabola would open upwards. Positive number opens upwards. Negative number opens downwards. Let's talk about one more thing. You'll notice that with our previous example that we did on the last page, y equals x squared, and then y equals 2x squared. If you notice something, you notice that this one indeed got narrower compared to the original one. And that's because when the a value of the vertex form, when the a value is more than 1, the graph is going to get narrower. And if the so then that basically means it would be a vertical compression. And if the a value is less than 1, for example, a fraction like 1/2, that means it's going to get wider. So if we did y equals 1/2 x squared, that means that this whole equation, this whole graph here is going to actually get wider instead of skinnier like this one. So that's just something to keep in mind, something you'd probably want to know.